I wouldn't trade my experience here for anything else. That's for sure. And I think I even noticed in the classroom, you talk about doing group work. It's so different working with someone who's been in, the kind of environment that we have as compared to someone who's just been a student. That's for sure. You notice it on a day-to-day basis.
Welcome to the Blind Apex Podcast, where amateur club racers tune in to get faster.
This episode is brought to you by DeechWorks Fuel Systems. Follow them on Instagram to see what wild builds are using DeechWorks components. And if you need any fuel system components, visit DeechWorks.com for all your fuel system needs. Before we get started, we're recording the weekend after Thanksgiving, and I want to say thank you to my listeners. The data, I'm a data nerd. The data shows you guys have been sharing the podcast, especially during the Thanksgiving time frame. I'm sure you're torturing your family with it. But if you want any podcast to grow, you have to share it. It looks like you guys are. I appreciate it. Thank you guys for listening and sharing. As always, I'm your host, Kanjan Turk, and on this episode, I want to talk about Formula SAE. It's sort of been dabbled on. I've had some guests who are in programs, but I wanted to talk to somebody in a program. I probably would have changed my major if this was at a university I was going to years ago, many years ago at this point. But then I'd end up an engineer, and I think I can do that. I do that already. I play engineer in my garage all the time. But joining me, member of the Virginia Tech's Motorsports Group, someone who says he's usually chained to an engine dyno, which kind of intrigues me. That's really up my alley. Ryan Piles, welcome to the podcast, sir.
Hey, thank you for having me. I'm working as the engine development lead for the Virginia Tech Motorsports team. We're a 36-year-old Formula SAE team here in Blacksburg, Virginia. And it's hard to say that it's not one of the best programs I've ever been involved in my life. And it's most definitely the best teaching program that we have here at the university. That's for sure. I love it. And I'm excited to be here and kind of share what we do today.
Yeah, I think it's going to be super informative to maybe folks still in college, those folks who have kids who are looking to get into college. And I'd like to provide some perspective to you guys as students who are in the program now on what we can help with, what maybe, I don't know, what can happen post-graduation for you guys. So, but before we go too technical into Formula SAE, when did you decide you were going to be an engineer and pick Virginia Tech and do all that?
Yeah, so it's kind of it's one of those stories where, as a kid, my parents always noticed that I was like fascinated by certain things. I just always was like, from a young age, maybe just a couple of years old, would just be taking stuff apart, messing with things. It was funny. We had a CD player in the house. I think I'd always take apart the CD player and put the CD player back together with a screwdriver. And Mom and Dad, they kind of knew from an early age. And I think I had a cousin who was like one of the earlier people involved in engineering in my family, who kind of influenced it as well. They were like, man, he's going to be an engineer. He's just got it. He's got the knack. He knows he wants to be an engineer. He'll realize when he grows up. And kind of just that, in combination with just always being fascinated about cars. It was, another young thing. I think I was fortunate enough to be born right around when the first Cars movie came out. And, that was a real hit with the, with my age group for sure. So it's just, certain, different influences from, what I was watching on the television as a kid and, just seeing cool cars around, going to the Philadelphia Auto Show every year with my dad. We do a little bit of work on something small in the garage, sometimes routine maintenance, stuff like that. Just little things like that kind of like built up the knowledge of, cars are really cool. We're paying a lot of attention to cars. I definitely had like a knack for working with my hands, doing the physical stuff, but I never really had gotten that into, engineering or really the automotive side of engineering until about high school when I had met a friend who was really into motorsports, and he was kind of my introduction into the IndyCar and F1 space. And I think the moment I kind of locked eyes with Formula One, I just kind of built this huge like fandom of everything. And I was like so enthralled by all the aerodynamics and the crazy engineering principles and the huge dollar signs next to every decision that they made. So it was one of those things where, when it was time to, up and figure out what I was going to do for school, it was like, how can I do that? That's exactly what I wanted to do. Which kind of led me down the road of, let's pick colleges that have something related to automotive. Any school that, had maybe a Baja SAE team or a Formula SAE team or something of the sorts, those were the schools that I was really considering hard when I was making my college decision. And it just so happened that I think Virginia Tech and Clemson were the two schools that I was considering that had, a Formula SAE program. And then they also had more of like an automotive focused engineering program to be a part of. Clemson, they didn't want me, but, we we went down the road. We applied to a bunch of other places. But I mean, I think when I came to Virginia Tech, a young lady at the time, Abby, had given me a tour of the Virginia Tech Wear Lab, which is where the Formula SAE program is housed. Mm-hmm. And I hadn't even realized the scale of the team that they had here and how old it was, kind of the history behind it, until I had really shown up face to face and got to see it for myself. And it was really a wonderful thing. I was pretty hooked. I told my mom that day, I was like, yeah, this is definitely where I'm going to go to college. Like I really, really liked it. I thought it was, not just like a really, really cool program, but I really liked sort of the level of, or the high level decision making that was very apparent in some of the work that was happening here at Virginia Tech as compared to some of the other schools that I had looked at, surface level things like just looking at a school that makes, a monocoque race car, a carbon fiber monocoque race car over, a steel tube, like a lot of other Formula SAE teams. Those little things like that when I saw it at first, I was like, oh, wow, some Formula SAE teams do that. So it was just kind of like hard to turn something like that down to potential opportunity like that. So kind of made it my mission to try and get into school here and try and get into that program for sure.
Yeah, I didn't realize that you guys were doing full monocoque carbon setups. So yeah, that's interesting. So educate me, the old man who missed out on Formula SAE even though it was around when I went to college, apparently. What is Formula SAE?
So Formula SAE, as the super surface level introduction, is a collegiate motorsports program that's not just in America, but across the world. There's about probably somewhere in the realm of 200 to almost maybe 300 international teams that compete in different regional competitions across the world, whether that be in a internal combustion vehicle or an electric vehicle. We are all making a set of open wheel, single seater Formula style race cars, a lot of which with full aerodynamics packages and crazy, design decisions, whatnot, on a college level and competing with one another at different competitions, depending on maybe what continent you live in. Here in the United States, we compete in the Formula SAE Michigan event, which happens at Michigan International Speedway every May. For combustion, I guess for Virginia Tech in general, we have both a combustion car and an electric vehicle. So we'll compete in both competitions at Michigan every year. Last year, we competed against 120 combustion vehicles. And then we also competed against around 70, I think, electric vehicles as well. So it's, at basic, it's a small single-seater Formula style race car, but there's really, for a lot of programs, no expenses, no design decisions. There's really nothing wasted. There's nothing spent. It is a full-blown race team on a collegiate level, whether it's graduate students or undergraduate students. And it doesn't really matter who you are, where you come from, what school you're at, how much money you have. It is really down to the engineer and how you take advantage of a rule set and the decisions you make to get there, and how your team performs on race day. It's a really, really beautiful thing. It's a cool competition. And I really don't know anyone, here at the other universities that we're close with, that wouldn't say it's easily one of the greatest teaching opportunities that exists in college, especially in the automotive sector.
Oh, I have no doubt about that, especially when you guys are as hands-on as you are. And I think we're going to get into that. But let's talk a little bit. Let's do high-level basic rule structure for Formula SAE.
Yeah, looking at the rule set, it's quite complicated in some respects, and in others, it's unique in the way it kind of delivers a large degree of freedom in your decision making. In terms of a lot of things like, say chassis, or maybe certain constraints with, how we're like any motorsports class, like how you're bolting connections, how you're making little decisions, are very, very tightly grounded in the rules. Especially on the chassis side, safety is a large factor for the program, and just kind of ensuring that, you send a bunch of students out in race cars, you don't kill them. It's extremely important that, that those rules are met, and there's, a very detailed failure mode effects analysis that's kind of required on certain components to, even be allowed into the competition, and, are used as grounds for disqualification. But on the other side of things, a lot of the other rules are somewhat freeing. It's neat. Every car, I was in a paddock last year of 119 race cars that weren't mine. And you look around, and every car generally looks similar, but every single one did the same thing a different way. And on a scale that large, you talk about 120 teams, it's pretty wild to see. I could look at every single car and find one, if not 10, maybe 15, 20 components that all kind of achieve the same goal with a wildly different engineering approach. And that's kind of the beauty of the rule set. And I think it's kind of where a lot of engineers strive in Formula SAE, is that, from a teaching perspective, there's a lot of ways to interpret different parts of the rule set. And there's a lot of ways to kind of go in and make it your own, in the pursuit of performance, right? And we talk about, a lot in our program about, we're always constantly referencing the rule set for the little nuances that, keep you within the legality of what is, the spirit of the racing, or the spirit of the competition. But we really spend 90% of our time just conceptually going through anything from, what is an aerospace company doing with this material? What is what's a Formula One team potentially done with, this type of component? There was some guy in his garage 10 years ago that had some crazy idea that never worked out, but like, maybe we have the resources to figure out what he couldn't, It's one of those things where the rules don't necessarily limit us. They just more so direct us in a certain way. The only really major rules that kind of limit us as a team are safety related items, like, chassis. They make us air restrict the engines, just so you don't make too much power. Try and, maybe introduce a, design problem there to deal with as an engineer. Otherwise, a lot of it is really, up to the decision of the engineers and the teams, and kind of when you determine that early design directive early on, how you're gonna approach these guidelines, maybe more so of the rules.
Yeah, I feel like they give you like my brief reading of them was they give you a big box to fit all your issues in, right? You have certain width parameters, length parameters, those types of things. But
totally. Exactly.
Generally speaking, they're like, okay, make this widget. But all the rule is the widget has to fit these pretty high level parameters. You're right. In some respects, they were dialing things in, but yeah, it was pretty interesting. So you guys have been around for, you said 36 years.
Yes, sir.
Does that mean there's 36 chassis, or are you guys recycling, evolving them? When do you decide when to scrap them? Like,
So in terms of a physical chassis, they can only enter a competition once. That is a rule. So once a year, you can use that throughout a 365-day cycle. Once that enters its first competition, it can't be used again next year.
Okay.
However, there are 35, I think. There should be, well, more than 35. We've had multiple 2-car years. There's probably somewhere almost close to like maybe 39 chassis in existence.
Mm-hmm.
Whether or not they exist with us, I can assure you that the majority of them don't. There's a couple that sit up in the shed. I think there's one on display in Roanoke at the Transportation Museum, I believe. I think that was a car from the early 90s. And then otherwise, a lot of components get, in that gray area of sold for donations or, worked out with certain alumni over time. I think it's always been different, just kind of, based on what years in leadership the team's had and whatnot. Right now we have, I think we have a 2022 combustion chassis that's like kind of together. 2023 EV, which was an 8th place finisher. It was a great car. That one's still intact in the showroom. And then, both of last year's cars, the EV and the IC from last year, are still together too. But nothing says that those cars probably don't get sold for some donation money soon. I mean, we kind of rely on that stuff to thrive. So it's one of those hard decisions we have to make.
Yeah, sold, cannibalized for parts, whatever. I'm sure there's bearings that got passed along or something, has been recycled into the new chassis. But
I mean, in terms of design, though, usually we usually start pretty fresh every year. It just kind of depends on what the design constraints are of that year and what the goal of the team is. I haven't really seen a lot of years where I haven't seen a lot of times where a chassis gets reused in terms of design more so than like maybe 1-2 years,
Right. But so what does the program, and I'm speaking broadly, right? Mm-hmm. What does the program look like where you scrap a perfectly good race car, draw a new one up from scratch, and then I'm assuming you guys are doing 99% of the machining, those types of things. So talk about what the program looks like at Virginia Tech. I know a couple of other schools like Georgia Tech and some of the other ones, they're different. They're set up a little different from you guys. But in general, what's your broad team look like?
Well, that is kind of the beauty of our program here at Virginia Tech too, is we're very fortunate to have, certain resources that allow us to do a lot in-house. In terms of the design process, we operate on a 2-year design cycle. So we'll spend all of the year leading up to our competition year doing design work, whether that's full team or part by part, design and analysis. We kind of try to scale that up towards the end of the year to be more of like a full car simulation and analysis and an understanding of what this full car is going to potentially be. We're trying to start at the beginning of the year with like the part by part. Hey, what's our individual design directive? How does that meet the team's overall goals? How are we going to hit the broad scope goals of the program? And then once we kind of get out of that design development year, the first half of that competition year turns into the big manufacturing push. And I think this is where we're really fortunate to have a program like ours where, not only are we just completely student led, unlike a lot of teams, we also manufacture just about everything that we physically can in-house. And that really spares just about nothing. I mean, we're talking about, we make a carbon fiber monocoque in-house, which is a huge, huge undertaking. I mean, every single task for our chassis is done in-house, just besides the curing process. So certain things like that is just kind of where, it helps us excel, not just as, engineers, but also individuals, trying to build ourselves for our career. That kind of experience of having really tight ties to, being the one that manufactures that part, being in the machine shop, understanding those kinds of constraints that need to be allowed in your design, it bodes well for kind of, furthering building that education as an engineer, right? Right in our lab here, the Ware lab here at Virginia Tech, we have a pretty large machine shop and access to three axis, automated milling, and at another laboratory we have access to even 5-axis automated milling, and we're kind of able to take advantage of these certain machines and capabilities to do just about everything you see on that car in house. And it's wonderful, whether it's manufacturing, fabrication, just little small making a bolt. Being able to do that kind of stuff in house is kind of a huge like ability that the program has that not a lot of others necessarily do or take advantage of. You mentioned like Georgia Tech or not to call them out or anything, but you mentioned some other teams that just kind of spend a lot more time in design and then kind of send a lot of their designs off to be made in a certain timeline. I think for us, it's much more of a personal grind and attachment to our vehicle. And I think it also really bodes well for everyone having, a deep, good understanding of what they're putting on the car as well. When it comes time to tune and optimize and kind of really, eke out the last, 5% of performance out of that car, having that kind of relationship with your part and having that kind of relationship with the car is kind of paramount to the success of our program.
Yeah. Well, you said you're in the engine dyno area all the time, but
yes.
What other, do you also do chassis design? I mean,
so I don't really work on. So in terms of design, like my whole design directive is related to engine. And I guess I kind of skipped over that a little bit. We have, our own lab spaces for engine and powertrain where we work on, developing electric powertrain in the same room as working on our combustion powertrain. And, one of the kind of great abilities we have here at Virginia Tech is an engine dynamometer, which, allows us to do a whole, slew of steady state and dynamic testing on our powertrains to kind of not only ensure reliability, but really dial in, our tune parameters and kind of have a very well done package, in terms of how it's going to perform, kind of knowing exactly what kind of power we're making, understanding how to properly gear the car. But even broader scope than that, like, in terms of powertrain, what we're really doing is we're designing a lot of supporting components and coming up with a good, really overall packaging constraint and determining like what would be the ideal designs to work with the rest of the team in terms of powertrain. So it's kind of interacting with a lot of aero guys, a lot of chassis guys, a lot of the suspension guys. There's kind of not a single part of the car that ours doesn't affect in some way. So, you talk about, I joke around that we're always chained to the engine dynamometer, but it's because we spend a lot of time doing a lot of testing and kind of trying to work to heavily validate the decisions that we make and the components that we're making in-house. We're making an intake in-house, we're making an exhaust in-house, we're making internal engine changes at times where, we need to fully understand, how that's not just going to, affect us in our performance, but also how maybe a change in performance is going to affect, a related subsystem of the car, and how, we're going to make sure that that's well communicated and that, nothing's really missed in terms of performance in any aspect of the vehicle.
Yeah. So I know, I just know a couple people from the Georgia Tech team. Or former Georgia Tech students that were on the team.
Sure.
They incorporate their business school into their Formula SAE team strictly on marketing and management side. I don't think Virginia Tech has a business school. I could be wrong. I haven't.
We have a business school, yeah. And funny enough, it's funny that you mentioned that because as of late, I think really starting last year, we kind of started a more of like a media marketing business related part of our team. And I think funny enough, the person who set up this podcast is the business team lead. So okay. he and his group of people they're kind of leading, what is kind of a new effort for us in terms of marketing and media and kind of just like trying to build a better brand image and go out there and maybe attract more sponsors or benefactors of the program to try and kind of, help us build up where we can. But yeah, I mean, it is a good point of note. These teams are really well rounded in a sense where there's a lot of, it's very interdisciplinary. Not everyone's just, like myself, a mechanical engineer, right? There's plenty of people that are, we have a business student, we have a marketing student, we have an electrical engineer, you have a mechanical engineer, you might have a computer science. I think you might have a computer scientist. I think we had someone recruiting who was in, data sciences or something like that. And, this sort of thing, it actually really, it comes to benefit us having a lot of different people from a lot of different backgrounds at times because, it helps build a more well-rounded program and having all those skill sets in there, helps you make sure that you're not missing, a little thing somewhere that could really help in kind of that full team development,
Yeah, and in the grand scheme of things, it's all the different perspectives from all the different disciplines will help the program overall, right? So expanding it absolutely helps. So one of the things I wanted to talk about, because I know a carbon guy, you guys are building your carbon in-house. Are you building shocks in-house? Are you using off the shelf and modifying them? Like, let's talk about like how nitty gritty you guys are getting in with your hands.
So it's a good point. Yeah. There are certain components that are purchased off the shelf. And a lot of times when we make those decisions, it's usually one of those where it's like, it's not always, can we make it in-house? Is it worth it? Like, are we investing that kind of time and money into something where we're going to build something that's potentially of equivalency to what you might be getting off the shelf? Or, maybe, X company can hold that extra thou tolerance that we can't in manufacturing or, something like that. I think, in terms of like suspension per se, it's, just about everything besides the spring and shock assembly is made in-house on the suspension. We run a full double wishbone, a full double wishbone suspension with push rod inboard shocks. And the shocks are purchased off the shelf. I think we are recently started using Multimatic branded springs and dampers, but that sort of thing, suspension, like on the suspension side, shocks is the only item that's getting purchased. It is interesting. Certain teams are getting more into, say the nitty gritty than others. It really is it is a scope thing like that. It's, what is the decision making behind possibly getting a part off the shelf versus making it in-house? And it's a big consideration for the competition as well. We talk a lot about when you go to competition and you sit in front of design judges and you talk about a lot of the design considerations that you made. The right answer isn't always that I made it myself, and so it's better because I made it myself. There's a lot of different scope considerations made in terms of where we decide to potentially purchase something off the shelf and where we decide to make it in-house. But I mean, I think just kind of broad, bigger picture stuff. I mean, the only major components, looking at the car that are purchased and not made in-house are, electronics, even though we run in custom software on all of them that's made in-house. The actual physical engine casing and some of the internal components are purchased. The shocks are purchased and occasionally, depending on the year, maybe it's a purchased muffler and say a purchased differential. And I think outside of that, you can't really think about I can't really think to find another major component on the car that isn't made in-house. And I mention chassis a lot just because chassis is one of those bigger things where, making a carbon fiber monocoque is a huge undertaking in terms of, not just the design. I mean, the scope of the design is beyond most undergraduate level engineers. And in fact, I'm pretty sure in industry, it's a minimum PhD requirement to kind of even get that sort of job. As well as the fact that, making certain components like that is just, it's so complex, and it requires so many of these multi-step manufacturing processes that, we do a absurd amount of work ourselves for a team of undergraduate engineers who are really, a lot of people, this is their first time, potentially ever making a real physical part as an engineer, in their career. So it's a cool program in that aspect for sure, but it's definitely just, one of those things. It depends.
But are you guys making wheels in house?
So we have in the past.
Okay.
Yeah, that was another good one. We currently purchase wheels. They're magnesium alloy OZ wheels that we purchase, and they've kind of become popular the last couple of years around a lot of teams, just because really low rotating mass, as well as it's a desirable dimension set. But we have in the past, we experimented for some time. I think back in 2021, maybe a little bit in 2022. It's my memory is lacking here a bit, because that's around when I joined the program. We were experimenting with making carbon fiber wheel barrels in house and having a 3-piece wheel assembly, where it would have an aluminum inner and a carbon fiber barrel. But I think we had just scrapped the idea because we had a grand idea that, it would be okay if it met these exact specs after manufacturing. And I think we just weren't exactly there in terms of maybe the weight or, kind of the surface finishes that we were getting out of it or something of that sort. And we determined it just wasn't necessarily within the scope of what we needed to do that year.
Yeah. And like you said, there's things that you can buy and there's things that you can make, and
Yep.
The business guys will come out and be like, well, do we have the money for it? And then the program manager will be like, do we have the personnel to do the job and get it all done? Right. And so there's this, you're balancing, right? Not only are you engineering it, but this program that you have has to be balanced out. So you can't just do everything, right? And especially to the tolerances that a wheel needs to be, like, that's kind of a big deal. So
yeah, definitely. It's one of those things that the managerial side of it is a huge balancing act constantly, like you said, of kind of putting your resources in the right places. It's definitely kind of a big factor of where you might pick up your successes and where you might create your own failures. I think, it's important to get that 95% of the engineering, but a big thing that we always like to say in the team is, you can do 95% on the computer, but the last 5%, you can sit there trying to eke out the last 5% on the computer, or you can make up the last 5% on track. And I think a big thing too is there's always going to be certain items or certain decisions that you want to make that might just not be worth it because it extends our timeline. And wanting to get a car on the ground as early as possible is kind of one of the biggest considerations to make as a Formula SAE team. I mean, you have essentially 1 year to build and learn your car once it's on the ground. And, the more time you drive that car, inherently, the faster it gets, the faster your drivers get. It is so important to not get caught up on that last few percent in design of, like, theoretically, this is a great idea, but if that theory takes too long to implement, or it's too wasting, or, it's just not going to yield, more than, like we say, that last 5%. There's just no point, right? You might as well get on track. You might as well spend that extra 3 days making more suspension changes and learning how to, get that car working just a little bit more to how you wanted it to be. And maybe throwing a slightly different tune at it, getting a little different transient response, certain things like that are way more beneficial than, making such a weird, little decision on one component that, inherently isn't going to make the car any faster than the great suspension setup would. Right. So you just gotta weigh your wins and losses at times, right? There's a lot of great design decisions made, and there's a lot of ones that could be done, but you have to determine whether or not they're really ever worth it or within the scope.
Yeah. So this podcast does a lot on the driver. We talk about changing the car and stuff too, but we work on ourselves the most, right? As drivers. Yep. And But the time you can do that in parallel, so developing the car and developing the driver, you eke the most benefit. At least that's what I've seen. So being flexible, getting it on the ground so it can be used, it can have the data recorded, and then you yourself can I'm assuming that it's in-house drivers, right? Team members are drivers.
Yep. Yeah. Myself being one of them as of just a few weeks ago. But, a big deal is just, having a car on the ground, getting seat time and getting data. You're so right. I think that's one of the things we did really well this year. We're all really proud to talk about how, just a few weeks ago, we went out and won a competition down with Michelin in South Carolina, the Formula SAE shootout hosted by Michelin every year. We went down there and, beat what were two of the better teams in the country. Where last year, I think at competition in Michigan, we felt that we were a little bit slower than them. And I think a lot of that just has to do with, we've been building a car all year. I mean, we're weeks away from driving a brand new race car, but last year's car never got decommissioned. We've been machining all week and driving every weekend. And I cannot stress, I can't stress any less that like we've been driving every weekend up until pretty much last week. And that sort of thing has been really, really paramount to the success of the team this year, and kind of like where we all feel as, a driver, a specialist, a team lead, whatever your position might be on the team, having that kind of really, really tight overall understanding of, this is how the car is this is how we developed the car. This is how the changes that needed to happen throughout the year to make the car faster. We went out there and we had a car that was easily, I'd say if we put the competition spec car on the track and we put that car last, 2-3 weeks ago on the track, same track, we probably would have run a lap 3 or 4 seconds slower in that previous iteration of the vehicle. And on a 50-second lap, 3 to 4 seconds is, that's a big deal. That's almost, 5-8% of your lap time. So, we just kind of talk about, you talk about doing things in parallel. And I think it's a huge point that the teams, this current, version or life of the team is certainly learning is, to do as much as we can with our time is paramount to success. And, we're kind of looking to continue that now. I mean, we're about to have a car on the ground, the earliest in team history, not just by, maybe a week or two, but we're talking like 2-3 months ahead of any schedule the team's ever held. And it's just one of those things where we're really, really pushing for, seat time. The seat time is going to be huge for this team and kind of for our development and just trying to build a better race car. Right. And I'm sure you can relate, as a driver, you need to be there and really experience it to understand the nuances of that car. Every new vehicle has its weird little quirks and issues that need worked out or things that need tuned around. And, it is so, so important to actually have a vehicle going to learn those things that you got to be working on. Right. So, we stress it constantly. And I think right now the current state of the team is doing a great job of just kind of getting in there and getting as much done in the little amount of time that we have to kind of maximize that potential. You know what I mean?
Yeah. You mentioned Michelin, and I was going to talk tires. I'm assuming they're a spec tire for the competition car.
Not necessarily. I'm pretty sure now that, throughout the years, there's been different tire manufacturers, whether or not they make something that's sized for what we do and kind of built to the specs of what we do. Hoosier is like the big company that kind of makes a lot of the racing slicks that teams use. And I think now Continental is making a set of slicks as well, but it's for kind of a less traditional wheel and tire size than what most teams run. Most teams are out there running like 10-inch diameter wheels and tires, or 10-inch diameter wheels, with like maybe a 6-inch wide or a 7.5-inch wide tire on them.
Okay.
And then there's other teams that are running 16 inches and something similar in width. So, or I think 7.5 to 10 inches in width. It just depends. A lot of teams maybe decide differently on kind of the load cases and the overall footprint of their car, what they might choose. But yeah, Hoosier and Continental right now seem to be the only two manufacturers that kind of bring anything in.
Mm-hmm.
Both I'm pretty positive offer different. I mean, I know Hoosier offers different compounds and stuff, different widths, different compounds. There's a whole set of, tire data out there to kind of maybe determine what might be more beneficial to choose for your car, kind of based on the tractive loads you're going to see. But yeah, in general, it's not spec. Yeah, there's very few things that are spec with what we do. I mean, again, the rules and a lot of that stuff sticks to being a guideline just about everywhere. Not to say that a lot of people don't make a lot of similar decisions, say in tires, because maybe one size or one combination is really the more obvious decision, but it just kind of it depends.
One thing I wanted to talk about, and you mentioned a little bit because you had 5-axis and 3-axis mills. What kind of tooling are you guys in general getting used to? You also said that you don't do the curing of your carbon fiber in-house, but I'm sure you're doing vacuum molds and things like that. So let's talk about the complexity of the processes you guys as engineers get real life exposure to.
Yeah, so I mean, on the composite side first, we don't do the curing of the chassis and a few large wing elements that are made out of pre-preg carbon fiber in-house. That sort of, we just don't have an autoclave here that's large enough. We have a sponsor that we work with though, and they donate some of their time to us. And, we'll go out there and cure a couple parts and, get out of their hair. But outside of that, a lot of the other smaller, and I say small, but anything that's not really more than a couple feet in size gets made here in house, whether that's cutting carbon, laying up, maybe it's not a pre-preg part, maybe we're doing a resin infusion, or we're doing a wet, just a traditional wet layup where you're squeegeeing on resin, or vacuum bagging, curing in house, whether it's hot cure, room temperature cure. We have a whole laboratory space, purely dedicated to manufacturing composites, which is really nice and beneficial to us. But yeah, I mean, just about everything is done in house. I mean, on the more metal working and fabrication side of stuff, all of our welding is done here. We get tubes bent from a supplier, and pretty much it's about the only process that's done on that side outside of here. All of our welding's happening here. We're making jig plates. We're, making all these different types of fixtures. We even, in manufacturing for, say chassis related components or suspension components, 3D scan parts during manufacturing, tack them up, 3D scan them, compare them to the CAD. How tight of tolerance are we holding? What might need to be tweaked, adjusted? How are we going to ensure that we are, holding the tightest tolerances so that we, minimize our compliance on car. And, outside of that, just in the machine shop itself doing, we get a bunch of donated tooling, and, everything else is pretty much up to the imagination. We try and design a lot of parts to be as manufacturable as possible. If it can be done on a manual mill, it's going to be done on a manual mill. If it needs to be done on a 3-axis mill, it'll be done on a 3-axis mill. Certain parts, we know we're going to hold certain geometry. It needs to be done on a 5-axis mill to, save, time and human resource. And we have limited windows for everything. So a lot of the decision making there, and even in the machine shop, we don't necessarily make a single component that has to be done a certain way, right? It's that, maybe we choose to do it on a 5-axis mill because it's going to save us all that time and what it would take in fixturing to do it on a 3-axis, or do it on, the 4th-axis edition that we have in another mill, or, it really depends. But these are all the kinds of decision-making that happens, not just after the part's designed, but while you're designing the part. We know kind of how we're going to allocate our resources well ahead of time to kind of, make sure that we're not backed up in the machine shop, to make sure that we're utilizing, every machine in a way that's not putting someone else's part aside. Everything really has to be done in such a tight window, and there's such a large volume of parts that come in and out of, every manufacturing space, that we really have to tightly budget that time and effort, as well as, even talk about tooling. We have, you allocate certain tooling to certain machines, and, you got to keep things done in a way that it's well organized, but, it's organized in a way that everyone knew it was going to happen that way. Everyone knew it was going to work that way. Right. And that kind of just starts way early on in the design process.
I think you guys, I think this program is so beneficial to you guys as future engineers, right? To American manufacturing in general. It will save headaches in the future for the people who hire you guys. I mean, you guys do everything from the tolerances to putting your hands on it, to making it, to assembling and testing it, seeing what works, seeing what doesn't work, seeing what your design influence had to make things easier, right? I can't tell you how many mechanic friends of mine are like, these darn engineers, and I'm like, it's probably not the engineer, it's probably the bean counter that did this. But why would the engineer make you have to remove an axle before you could remove a oil filter, for God's sakes, right? Like,
well, that's a great point. It's a really good point, right? Like, a lot of engineers, and I watch it even here in my classes, right? Like, I'm friends with engineers who don't get involved in this sort of program, right? And a lot of engineers, right, the stereotypical joke is, well, he's just an engineer. He didn't know any better. Now it's not manufacturable. He was just an engineer. They didn't look at it on a full scale. Now it's not serviceable, right? And like,
right.
You build a purpose-built race car, and I think we even talked about this right before the show started. You build a race car, your trackside, something went wrong, it needs fixed instantly, and you need to be able to do it easily.
Right.
And, in terms of like, yeah, you mentioned the serviceability aspect, these kinds of considerations, being, exposed to that design constraint early on with a program like this is huge for the development of any engineer, right? Like, a big thing that, you just can't teach in the classroom is, how are you going to understand, the effects of your decision making on a full scale? And, whether that's the part is now in the vehicle, how did you ensure 50 steps ago on the version 1 of the design that it was going to be serviceable because you were doing it that way? Or, the guy in the machine shop is, pissed at you because you made the wrong decision, and you're not ever going to, fit a mill inside that crazy little space in that part and, make that pocket that you wanted. Right. How do you start from version 1, knowing that these constraints are always relevant to your design? And I think it's one of the benefits of, not just our team, any team, in Formula SAE or, any sort of competition like this is, ensuring that you're able to think on that full scale and make those decisions early on, because you're right, it saves the headache like crazy, and in industry, that kind of stuff is invaluable because you're not just saving yourself time and, maybe a pretty angry talk with the boss, but you're saving a company a lot of money and effort. But time is money, and, to make those right decisions early on, should definitely, bode well to making a better engineer early on as well. Right.
Yeah, I absolutely agree with you on that. What on the program side have we not talked about that you think we should?
I mean, I think we have like a good overall scope. I mean, I think we always talk a lot in Formula SAE, just kind of, it looks really cool. And then you have some people who are like, well, what even is it? And I don't think it's necessarily like comes down to like, what is the car at the end of the day? I think it's a lot of, what is it making us? And as the engine, as one of the engineers involved in this, right. And, as a team lead now, I mean, I've been in this program for 4 years. It makes you a more well-rounded person for sure. I mean, as a student, I'm taking on a level of, work outside of the classroom, responsibility outside of the classroom that, a lot of people just don't see. And, or I guess I say a lot of traditional, engineering students might not see, and in a program where it's already, there's already a lot expected of you, whether that's your time or your effort, right? That little extra bit of time and effort and education and stress at times, and they all work really well towards kind of building yourself as a student, as an engineer, but also as an individual. You learn a lot about working with other people and what it takes to be successful in a team environment like this. And every single individual's decision affects another's, whether that's physical on the car, maybe emotional. These kinds of things are, I've already seen it, firsthand. I come from a family of business owners, and like you see a lot of it when you work with other people, differing people. That it's important to holistically consider your decision making and kind of understand what what's right and what's wrong, not just in terms of a design decision I'm making, but how is it going to affect this person as my friend, as my colleague, as my coworker, right? I think it's a really good, like, overarching teaching opportunity for everyone just to kind of, better themselves as a person, as an engineer, get exposed to something really, really cool. But, in general, I think this is the start of everyone's, professional, and adult lives. And it's a wonderful thing to be a part of, for sure. I can go on all day about, the great engineering and, like I said before, there's nothing, we spare no expense in terms of time and effort and decision making. And it at the end of the day, it's a wonderful program to be a part of. And it's wonderful for me too, in my position, to be a teacher to others, and to have built a skill set in 4 years where, I'm sitting in front of a classroom full of people teaching people, and, I enjoy every second of it. And I think it's, I think this kind of program is really good for that sort of thing. You know what I mean? Like, just really building yourself up personally.
Yeah. When I was in college, I would always be like, why are we doing this? This project why is this a group project? Formula SAE is the epitome of a group project in a discipline that requires that type of coordination, right?
Absolutely.
It's way over the top. Like, my head is like, oh, why would I do that? Why would I voluntarily do that to myself? You kind of have to think about it, because you guys as young adults are going to enter a space where working with other people in other similar disciplines, right? Okay. So you have the suspension people, you have the motor people, you have all these people working together in the automotive realm. They literally have to work together. You cannot build your widget on your computer screen by yourself. It just doesn't work that way. Not in a large manufacturing complex issue. I think Formula SAE puts you guys over the top on a resume when you come out of college. It just must.
Absolutely. That's our goals too, right? I think everyone in this program has a great work ethic and is really motivated by that idea of, I want that great job when I get out of school. I want to build myself now so that, I benefit, someone later, and, I can be, an asset to maybe a company or the project I really wanted to do as a professional. Right. It's super cool in that respect. That's for sure.
Yeah. And it's got to infuse professionalism and passion for your discipline, right? It's molding you guys into future amazing team members for business, for American production. So I think it's an amazing program that if people aren't in college yet and you want to do engineering or you want to learn how to develop things or, in that realm, you need to go find this type of program. I know you mentioned like the off-road one. I can't remember what that is now.
Baja.
Yeah, the Baja SE. There's several different types of programs, but in general, this is the pinnacle of all of them right now. I think it's been the longest standing one. And there's a lot of resources behind it at a lot of institutions. So it's a great way to really develop the next generation.
Absolutely. Yeah. It's a great project for sure. I wouldn't trade my experience here for anything else. That's for sure. And I think I even noticed in the classroom, you talk about doing group work. It's so different working with someone who's been in, the kind of environment that we have as compared to someone who's just been a student. That's for sure. You notice it on a day-to-day basis.
Yeah, I have no doubt about that. So how can us old folks, non-students, or businesses help get involved or support you guys?
So that's a great point. A program like ours, especially where we don't really receive a lot of benefit from the university. In fact, we pretty much receive just about nothing from the university in terms of funding. It is super important for us to build relationships with people, corporations, businesses alike that are looking to recruit engineers, and in turn we kind of trade that for monetary donation.
Mm-hmm.
And that's kind of the backbone of a program like this. I mean, you don't get to wake up and buy aerospace grade materials with no funding, right? We talk a lot about you talk a lot about building professionalism and whatnot. And I think a lot of that comes from interacting with sponsors and donors. And we rely heavily on that. We do a lot of outreach on that side. And it's paramount to the success of our program that we don't just, build a good car, but we sell it first. And I think it is, the unsung heroes of our program are definitely our sponsors. I mean, we give them as much recognition as we humanly can, just about everywhere. But it's the backbone of our success is having, companies that we can rely on and people that we can rely on to help us, put on a project like this every year and, be able to continue to develop ourselves as engineers to go into industry. So we have a program set up where, whether you find us online, our website, VT Motorsports, or on social media, VT Motorsports, there's multiple avenues of reaching out to the team to kind of potentially be a sponsor and, go through that exchange of maybe, materials or a monetary donation, a tax deductible donation, that is, to a program in turn for, potentially being able to recruit students or make an outreach event at the university or, anything of that sort. But it's paramount to the success of our program that, people are willing to get involved and kind of support that education of youth engineers. I'd say it's a good factor. It's a good, forum of people to support. It's just finding people who are generous enough to do so.
Yeah. To be honest, it doesn't matter whether you're looking to hire an engineer or not. If you're in the motorsports realm, you could probably use being involved, right? And then if you do have an engineering firm or company or whatever needed that, you're helping those people, right? And you're going to have early access.
Absolutely.
Just by meet and greets and all those sort of things. But for people who may be on the fence, are your competitions open to the public?
So the main competition every year in Michigan, that competition is definitely open for certain spectators. I believe you have to apply online to be a spectator at the event, kind of go through like an application process. But as far as I'm aware, it has been and will continue to be one of those things where it is open for certain people, especially those who are looking to kind of support maybe the overall program, Formula SAE, internationally, or kind of support an individual team, that you're more than welcome to kind of apply and try and get into the event. And then just in general, I mean, we do regional races throughout the year. I think that, depending on who it is, if it's something that, someone's interested in seeing, for the sake of probably potentially supporting a program or, multiple programs, You reach out to a team, talk to them, find a way to get involved. Especially ourselves. I mean, we're very active on social medias, and we have very obvious means of getting in contact with us over our website or maybe on LinkedIn or anything of that sort. It goes a long way to work with different people in different companies and for people to get involved in the sport. I think you mentioned before, I think it doesn't really matter what you're involved in necessarily. It seems that there's a benefit for just about everyone to kind of get involved in something like this and support education in that sort of way.
Yeah. And you have the resources for your program. You guys have, it seems like, a great amount of resources to give you guys the best type of exposure and experience before you leave college. And as a sponsor, you can help guide that, right? If you needed something, they could maybe provide it. If you were looking to do some sort of testing, maybe they have more bandwidth on their side. There's multitudes of ways, because I was looking at your sponsor packages, and it does talk about, basically trading equivalent material instead of dollars, those types of things. So
Absolutely.
Reach out to your teams, your local teams, and find out what they need. This is the future of American manufacturing in a nutshell here. And so we're looking at it, and it happens to be focused in a passion of mine, which is motorsports. So it's an amazing program, and I really appreciate you coming on and sharing with us.
Yeah, no, absolutely. And I thank you for having me today. I think I had, it's nice to bring light to this sort of thing. I think with certain industries and certain people, it flies under the radar, which is a real shame, because the kind of stuff that we're doing is really, really, really important to, like you said, building, a better base of engineers or students in general that are going to go to the workforce here in the United States or maybe abroad.
Ryan, thanks again for coming on, man.
Yeah, thanks a lot. Thanks for having me. It was real fun.